Today we are going to discuss universal and existential quantifier. So this is a continuation of our lecture last time about propositional logic. So in last lecture we discussed in detail about implication, its equivalence, its negation, bicondition, and different logical operations. So today we are going to quantify our propositional statements. क्वांटिफिकेशन का मतलब है कि हम कुछ नंबर्स की बात कर रहे हैं कि हमारी एक स्टेटमेंट कितने ऑब्जेक्ट्स कितने एलिमेंट्स के लिए ट्रू होगी. So we will quantify our propositional statements. It is true for like how many elements about which we are talking. So before moving to quantification, there is something important. It's called propositional function. Yes, हम predicate भी कहते हैं. So हमारी कोई भी remember propositions are those statements about which we can say whether they are true or false. अगर किसी भी statement के बारे में हम कह सकें कि ये true या false है, it's called proposition. Propositional function is just like the function that we use in our programming language. For example, when we give some input to our function, जब हम coding करते हैं function, we write down the function, so we give some input and we get some output. So we have some functions, Boolean functions, we get a Boolean output. Boolean output is either 1 or 0, true or false. So we give some input to function execute all its statements, and finally it will return a value. It will give an output, true or false, 1 or 0. So a propositional function भी इसी तरह का है कि it has some variables. When we give value to variables, the statement, propositional statement, becomes true or false. When we were discussing about proposition, over there we saw some proposition like x plus 2 is equal to 11. और वहां पे हमने कहा था कि इसके बारे में हम कह नहीं सकते कि ये ट्रू है जो फॉल्स है, क्योंकि हमें x की वैल्यू पता नहीं है. लेकिन अगर हमें x की वैल्यू पता चल जाए तो फिर हम कह सकते हैं कि इट इज ट्रू और फॉल्स. सो x plus 2 is equal to 11. इस तरह की स्टेटमेंट इज प्रेडिकेट या प्रोपोजिशनल फंक्शन, जिसमें अगर हम x की वैल्यू इनपुट दें, we will get an output true or false. x plus 2 is equal to 11. Suppose we call it p of x. इसमें वेरिएबल x है, so it's a function of p, it's a function of x. So x plus 2 is equal to 11. If we give value of x as 3, so 3 plus 2 is equal to 11, it's going to be false. So we can get a proposition that is a false proposition. If value of x is, for example, 9, then 9 plus 2 is equal to 11, it's true. So we can say that this is a true proposition. So कोई भी ऐसी statement जिसमें we have to give some input and then we get an output as true or false, इसको हम predicate कहते हैं या propositional function कहते हैं. For example, let q x y z denote the statement x square plus y square is equal to z square. So यहाँ पे हमारे पास तीन वेरिएबल्स हैं x y z. अगर हम इनको कुछ वैल्यू दें x y और z को, some numbers, so we will get some output whether x square plus y square is equal to z square, it is true or not. अगर तो वैल्यूज ऐसी हैं जिसके नतीजे में ये ट्रू हो जाता है, so we will get the output true, या वैल्यूज ऐसी हैं जिसके नतीजे में ये ट्रू नहीं होता, so we will get the output false, 0. So we can, for example, evaluate what is the truth value of 345, Q345. X square plus y square is equal to z square. We can see this is just Pythagoras theorem. X square plus y square is equal to z square. It's just a formula for Pythagoras theorem, which is for right angle triangles. X is base, y is its altitude, height, z is its hypotenuse, diagonal. So base square plus height square is equal to hypotenuse square. x square plus y square is equal to z square. So if we give values 3, 4, 5 as input, so we can see 3 square, x square 3 square, y square is 4 square, z square is 5 square. So 3 square plus 4 square, 9 plus 16. So this is equal to 25, and 5 square is also 25. So 9 plus 16 is equal to 25. So 3 square plus 4 square is equal to 5 square. So it is true. So we get the value true. Yeah, q, x, y, z is true. Similarly, we can see what is the truth value for q 2, 2, 3. X is 2, y is 2, z is 3. So x square plus y square is equal to z square. It's going to be 2 square 4. So 4 plus 4 is equal to 8. On other side, 3 square is 9. So 8 is equal to 9. It's going to be false. 8 is not equal to 9. So if we have 4 plus 4 is equal to 9, this is going to be false. So we get a value false. So this is a propositional function. When we give an input, we get an output true or false. So it's also called predicate. It's called propositional function. In the last, how many values of x, y, z make the predicate true? इस केस में x, y, z की कितनी values इस propositional function को true करेंगी? So we can get many values because this is related to Pythagoras theorem, right angle triangles. So how many values of x, y, z means how many right angle triangles we have? We have a lot of right angle triangles. In fact, we have infinite right angle triangles. So we can define, just make a right angle triangle and keep on changing the ratio of x and y, or just keep on expanding the right angle triangle. So it will never stop. We will keep on going. So we have infinite for which x, y, z make the predicate true. So here is the solution of our discussion. So the x345, q345 is true, q223 is false, and there are infinitely many values of x, y, z that make this propositional function true. Yeah, because we have infinitely many right angle triangles. Next is quantifiers. So if we have a predicate, a propositional function, if we have a predicate, it becomes true when we give some value to it. So for how many values this predicate is going to be true? So we are quantifying it. How many? Quantifying, हम कुछ नंबर की बात करें, हम इसको काउंट करने की कोशिश करें. For how many values the predicate is going to be true? So different scenarios में this number could be different depending upon कि आपका जो input size है, आपकी जो input है उस set का size कितना है. So if we are going to make a generalized statement, so we don't know कि किसी भी set में कितने elements होंगे, and we are trying to make it a generalized statement. So instead of counting 1, 2, 3, 4, 5, we try to quantify in more general terms. और वो more general terms हमारे पास दो तरह की है. एक quantification ये है कि आपका जो predicate है, आपकी जो statement है, आपकी statement तमाम values के लिए true है या तमाम values के लिए false है. It's true for all values, all, each and every value. It's true for each and every value. So एक इस तरह की हम quantification कर सकते हैं. दूसरी quantification ये है कि it's true for at least something. At least there is some element for which it is true. It could be one element, it could be two elements, it could be three elements, it could be all elements, but there exists some element for which it is true. So पहली quantification, it's like more strong statement कि आपकी जो भी statement है is true for all. दूसरी में it's not that strong, but at least we have to show some existence. इसकी एग्जांपल इस तरह लेते हैं. For example, we have Pakistani cricket team, for example. So we have 11 players. So हमारा input size क्या है? 11 players are our input size. And we are looking at ages of our players, and we say that all players are less than 40 years of age. जितने भी players हैं सब के सब 40 साल से कम उम्र के हैं. ये स्टेटमेंट ट्रू कब होगी? अगर तमाम प्लेयर्स 40 साल से कम एज के होंगे. If we could find even a single player who is more than 40 years of age, then we can say this statement is not true, because there is a player who is more than 40 years of age. लेकिन अगर तमाम players less than 40 years of age हैं, फिर जो हमारी ये statement है, all players in the team are less than 40 years of age. हमारा जो input size है, हमारा जो input set है, हमारा input set is those 11 players in our cricket team. And our statement is all players age is less than 40 years of age. So this statement is true जब 11 के 11 players सबकी एज 40 इयर्स से कम होगी. सो इस तरह के क्वांटिफायर को, इसको हम क्वांटिफायर कहते हैं. इस तरह की क्वांटिफिकेशन को, इस तरह की काउंटिंग को हम यूनिवर्सल क्वांटिफिकेशन कहते हैं. इसका यूनिवर्सल क्वांटिफिकेशन या यूनिवर्सल क्वांटिफायर के हमारी जितनी भी यूनिवर्स है, यूनिवर्स हमारी 11 प्लेयर्स की है. So each and every player is less than 40 years of age. हमारी स्टेटमेंट क्या है? Age is less than 40 years of age. Player's age is less than 40 years. और हमारा जो इनपुट क्या है? Players हैं जो 11 players हैं, and we check each and every player. पहले प्लेयर की एज it's less than 40 years, दूसरी प्लेयर की एज it's less than 40 years, and last player 11th player age is less than 40 years of age. So this statement is true for each and every player. So this is called universal quantifier. एक universal truth बन गया. जो हमारी universe of discourse है, universe of discourse means discourse is our like conversation about which we are talking. So जिस चीज के बारे में हम बात कर रहे हैं वो हमारी universe है. That set is our universe. So in this universe, this statement holds. In this universe, this statement holds. So we call it universal quantifier. ठीक है. The other is called existential quantifier. कि कोई चीज exist करती है, जो हम बात करें क्या उस context में कोई चीज exist करती है. For example, अगर हम इसी players की age वाली example लें, if we give a statement, there are players whose age is less than 25 years. टीम में कोई प्लेयर ऐसे हैं जिनकी एज 25 साल से कम है. अब ये स्टेटमेंट ट्रू कब होगी? इफ वी कैन फाइंड one player or two player or three player, if we can find some player whose age is less than 25 years, then this statement is true. There is some player whose age is less than 25 years. So जो हमारी universe of discourse है, जिस universe के बारे में हम बात करें, those are those players in our cricket team. So if there are some player whose age is less than 25 years, फिर ये statement true होगी. ये false कब होगी? If we cannot find even a single player whose age is less than 25 years, तमाम के तमाम players की age 25 years से ज़्यादा हो, फिर ये statement false हो जाएगी. Existence के लिए क्या ज़रूरी है? We call it existential quantifier. कि कम से कम एक player तो हो. वो एक से ज्यादा हो सकते हैं, दो भी हो सकते हैं, तीन भी हो सकते हैं, सारे के सारे भी हो सकते हैं. लेकिन एग्जिस्टेंस शो हो रही है कि हाँ ऐसी चीज एग्जिस्ट कर रही है. There exists some player whose age is less than 25 years. So this is called existential quantifier. One more example could be like अगर आप एक क्लास में जाते हैं, classroom में, and there are some students sitting over there, and you see all students are male students, yeah, female students, it could be either way. So suppose all students are male students. आप क्या कहेंगे? इस क्लास में सारे students बॉयज हैं, देयर आर ऑल बॉयज स्टूडेंट्स, ऑल मेल स्टूडेंट्स। और ये स्टेटमेंट गलत कब होगी? अगर suppose there are 20 students and all 20 students are boys, so you can say all students in this class are boys. लेकिन अगर कोई एक भी female student बैठी है, then you cannot say this thing that all students in this class are boys, because there is one or two or more female students. फिर आपकी ये बात गलत हो जाएगी. So the statement to be true, each and every student should be boy. या अगर हम स्टेटमेंट ये देते हैं, अगर all the students are female students, then we say all students in the class are girls. और वो false कब होगी? अगर दरमियान में कोई एक या एक से ज्यादा male students बैठे हैं, then we cannot say that all students in the class are female. So universal quantification, universal quantifier में it should be true for each and every element in our universe, in our set. जिस set के बारे में हम बात कर रहे हैं, set of elements, set of people, set of objects, जिस universe के बारे में हम बात कर रहे हैं, it should be true for each and every element of the universe. इसी तरह अगर in the class there are mixed students, some students are boys, some students are girls, so we can say that there are some boys students. अगर वहाँ पे कुछ male students बैठे हैं, we can say there are some boys students. और ये feel false कब होगी statement कि अगर कोई student भी boys I mean male student नहीं, सारी female students हैं, then we cannot say there are some boys students. या अगर सारे students are boys, so we cannot say there are some female students. So universal quantifier when it is true for each and every element, and existential quantifier when it is true for at least one element. At least one element लाजमी होगा, ये नहीं होगा कि किसी के लिए भी true ना हो. So a predicate, our statement, a propositional function, becomes a proposition when we assign it fixed values. However, another way to make a predicate into proposition is to quantify it, कि कितने elements के लिए ये true है. So a predicate is true or false, depending upon in which context we are talking. It could be true or false for all possible values in the universe of discourse. Then it becomes a universal quantifier, कि तमाम के लिए ये true है. Or for some values in the universe of discourse. Some values means कि कोई value exist करती है जिसके लिए ये true है, so this becomes existential quantifier. So such quantification can be done with two quantifiers, universal quantifier and existential quantifier. So let's discuss in more detail about first universal quantifier. So the universal quantification of a propositional function of a predicate p of x is it become true if p of x is true for all values of x in the universe or discourse. इसको मैथमेटिकली लिखने का क्या तरीका है? अगर हमारी स्टेटमेंट p of x है, so we write down for all x. This symbol is for universal quantifier, जो आपको शुरू में नजर आ रहा है. It's read as for all. So all start with a, so it's like upside down a. So upside down a is used for all. So this is a mathematical symbol for all. For all x our elements in our universe or discourse, जिसके बारे में हम बात कर रहे हैं. So for all x, p of x holds. For all x, p of x is true. So if we have a number of elements in our universe of discourse, suppose those elements are n1, n2, n3, nk. So universal quantifier के लिए जरूरी है कि आपकी statement इन तमाम elements के लिए true हो. So it should be true for n1, it should be true for n2, it should be true for n3, and so on. It should be true for nk. So in other words, universal quantifier is a conjunction. It's an AND operator. So for all x, p of x means it should be true for n1, p of n1 should hold, and it should hold for n2, and it should hold for n3, and it should hold for nk. So this is a conjunction. This is an and operator. Universal quantifier is nothing but an and operator. So and operator में आप याद करें जब हमारे पास दो वैल्यूज थी p q, सो हम जब ट्रुथ टेबल बनाते थे p and q का, सो वहां पे p and q is true when p is true and q is true. इनमें से कोई एक भी false हो गया तो and operation false हो जाता है. So our truth table, if you remember, 0 0 0 1 1 0 1 1. So हमारी output p and q output was 0 0 0 1. So ये 1 तभी आती थी जब p भी true हो, q भी true हो. अगर हमारे पास ढेर सारे variables हैं n1 n2 n3 nk, so it is going to be 1, and operation is going to be 1 when it is true for each and every value, when it is going to be 1 for each and every value. So if it is true for p of n1, it is p of n2 is also true, p of n3 is also true, and p of nk is also true. So their conjunction, their and operator is going to be true. So this is something that we call universal quantifier. So universal quantifier is nothing but an and operator. So it's just a conjunction. It should be true for each and every value. किसी एक वैल्यू के लिए भी ये false हो गया, zero हो गया, तो पूरी conjunction आपकी false हो जाएगी, पूरी conjunction आपकी zero हो जाएगी. Let's look at some example. So suppose we have p of x, we have a statement p of x. So x must take discrete math course. X is student. So x is, rather we make it more precise, it's x, our universe of discourse, our x is all UCP students. All students in UCP is x. So we can pick any elements from UCP student and we call it x. So p of x statement क्या है कि a particular student x must take discrete math course. Or we have another statement q of x. X is a computer science student. Okay, fine. Now we define our statements. We have a statement: every computer science student must take discrete math course. So we have every computer science student, every all का लफ्ज़ जब आते हैं, it means it's a universal quantification, universal quantifier. So let's try to express this statement mathematically. Express the statement mathematically. इसको हम mathematically express करने की कोशिश करते हैं. Every computer science student must take discrete maths course. Students की बात हो रही है, so we talk about x. X is UCP student. So for all x की जब बात की तो तमाम UCP के students आ गए. For all x, so computer science student. If a student is computer science student, then he should take discrete math course. So computer science student means it's q of x. X is a computer science student. हमारी जो statement q of x है, it tells us about computer science students. For all x, q of x. And what should q of x do? He should take discrete math course. So if a student is q of x, if a student is computer science student, then he must be p of x. Then he must take discrete math course. So this is an implication. So this is going to be for all x, tamam UCP students aa gaye, and then we take some subset of it. If this particular student is a computer science student, then he must take discrete math course. So ये जो हमारी statement red में लिखी हुई है, we can also say it. For all UCP students, if the student is discrete math course, then he must take, if a student is computer science student, then he must take discrete math course. Yeah, in other words, we can say every computer science student must take discrete math course. So this is a way to express our statements in mathematical notation. जब ये मैथमेटिकल नोटेशन की बात करते हैं जहाँ पे x यूज हुआ है, q यूज हुआ है, p यूज हुआ है, so these are variables, so we should declare these variables कि ये variables क्या है x, so हमें बताना पड़ेगा x क्या है. So x is all UCP students, so the universe of this course is all UCP students. These are our x. And then we have to describe q of x kya hai. So q of x is x is our some input variable. So q of x is a computer science student. And then we have we should also tell about p of x. P of x is x is going to take discrete math course. X must take discrete math course. So जब हम ये तीन चीजें define करते हैं, then we can write it down like this. So the statement will be complete by defining the variables and then expressing the statement into mathematical notation. It's just like when we are going to write our computer programs. So उसमें सबसे पहले हम अपने variables declare करते हैं and then we use those variables in any way that we want to use. So over here also we need to define our statements, our symbols, and then we can express it in mathematical notation. So every computer science student must take discrete math course for all x. तमाम students आ गए. अब उन students में से कौन से? If the student is computer science student, then he must take discrete math course. Let's do another example. So next example is everybody means every student. So every student must take a discrete math course or he must be a computer science student. So everybody means for all x, he must take discrete math course. So it's p of x or he must be a computer science student. So or he must be q of x. So statement is going to be for all x, all students, everybody, q of x, he must be a computer science student, or p of x, or he must take discrete math course. So this is just a mathematical representation of this statement. So which statement is true or false? पहली statement को अगर आप देखें for all x, q of x implies p of x. So we know like in UCP, if some student is computer science student, so he has to take discrete math course because it's core course. So first statement is going to be true. For all x, q of x implies p of x. क्योंकि आप किसी भी कंप्यूटर साइंस स्टूडेंट को आप देखेंगे उसका, if you look at his transcript, so he must have taken discrete math course. Second statement for all x, all students of UCP, q of x और p of x कि जो भी स्टूडेंट देखेंगे या तो वो कंप्यूटर साइंस का स्टूडेंट होगा या उसने की न की डिस्क्रीट मैथ पढ़ी होगी. अब ये स्टेटमेंट इट्स नॉट ट्रू फॉर ऑल एक्स. अगर ये होता देयर एग्जिस्ट सम स्टूडेंट्स फॉर व्हिच इट इज ट्रू फिर तो ठीक था, लेकिन तमाम स्टूडेंट्स के बारे में हम ये नहीं कह सकते बिकॉज देयर आर अदर specializations, other majors. Some student may be from like law department or from pharmacy department, so he must not be discrete math. He must not have taken discrete math course, or he must not be computer science student. So this statement is not true for all students. Okay, everybody must take discrete math course or he must be computer science student. So this statement is false. So next is existential quantifier. Existential quantifier is जैसे हमने अभी बात की कि there must exist some elements for which our predicate should be true. So existential quantification of a predicate is the proposition that there exists nx or some x, there exists some x in the universe of discourse such that p of x is true. इसको हम mathematically represent करते हैं. This is like a kind of E stands for existence, so it's a flipped version of E. जब हम यूनिवर्सल क्वांटिफायर की बात की थी उसका सिंबल क्या था? अपसाइड डाउन A था, A for all. Here E is like flip E. It's E for existence की बात हो रही. So there exist, इसको पढ़ते हम क्या है? There exist x, कोई वैल्यू है x जिसके लिए p of x is true. कुछ एग्जिस्ट करना चाहिए. So if we have universe of discourse, like we have a number of elements n1, n2, n3 up to nk. So existential quantifier means there exists, it should be true for at least one of these values. At least for one of these values, it should be true. So at least one of these values should be true. So ये हमारा और ऑपरेटर है. और ऑपरेटर में इस तरह होता है कि अगर कोई एक भी ट्रू हो गया, so it's true for the whole expression becomes true. और वो false कब होता है? अगर ये false हर एक के लिए false हो. So it's like a disjunction or operator. Existential quantifier is a disjunction. Existential quantifier is an or operator. So there exists x, p of x means या तो p of n1 true हो, या p of n true हो, p of n3 true हो, p of n4 true हो, या at the end p of nk true हो. किसी के लिए ट्रू होना लाजमी है. एक से ज्यादा के लिए भी ट्रू हो सकते हैं, सब के लिए भी ट्रू हो सकते हैं. Again, if you recall the truth table of OR operator, 0 0 0 1 1 0 1 1, p and q. So p और q क्या होगा? So p q अगर दोनों की वैल्यू 0 0 है, then p और q is 0. So otherwise 0 1 1 0 1 1 इसके लिए p और q is going to be 1 1 1. So output is 0 1 1 1. अगर तो p और q दोनों false है, तो फिर the operation disjunction p और q is going to be false. अगर किसी एक के लिए भी true है, so it's true. So if we have a number of elements n1 n2 n3 nk, इनमें से किसी के लिए भी हमारा predicate p true हो जाए, the whole statement becomes true. Okay, there exists something for which it is true. Existential quantifier. So existential quantifier is nothing but an OR operator. It's just a disjunction is OR operator. Universal quantifier was AND operator. Existential quantifier is OR operator. Truth values of quantifiers. So ये कब true होगा? Universal quantifier पहले. For all x p of x, if p of x is true for every value of x, and it become false, अगर ये किसी एक value के लिए भी false हुई, whole statement becomes false. If there is an x for which p of x is false, so this quantifier is false. And existential quantifier, there exists x for which p of x is true. So if there is at least one value for which p of x is true, so existential quantifier is true. And when it is going to be false, if it is false for each and every value of x. If it is false, then it is existential quantifier is false. यहाँ पे देखेंगे जब हम इसकी negation करते हैं, it is false. Negation means false. Universal quantifier जब false होता है, so we are looking for some value for which p of x is false. Means there exists some x for which p of x is false. So universal quantifier की जब negation होती है, we have something existential quantifier. Similarly for existential quantifier, इसकी जब negation होगी, जब ये false होगा, ये false कब होगा? It's false when p of x is false for all x, for every x. So there is some universal negation. Universal quantification false कब है? When there is some existential negation. और existential quantifier कब false होगा? When there is some universal negation. इसको हम अभी ज़्यादा डिटेल से डिस्कस करते हैं. Let's look at some examples. Product of two negative integers is positive. हमारे पास दो negative integers हैं, तो उनका product positive होगा. We know negative into negative is positive. whenever we multiply two negative numbers, we get a positive number. So it's like true, universally true. So we have universal quantifier over here. So let's try to express it in mathematical notation. Express it in mathematical notation. So जब हम इसको express in mathematical notation करेंगे, so this becomes product of two negative integers. So we take two negative integers, let's suppose x, y. So they belongs to set of negative integers z and minus. Z is our set for integers. जब इसके ऊपर हम superscript में plus लिखते हैं, it becomes positive integers. When we write minus sign, so this become a set of negative integers. So for all x, y, which belongs to set of negative integers, अगर हम इनका product लें x into y, so it should be positive. It should be belongs to z positive. Yeah, we can just write down x, y belongs is positive, so is greater than 0. So x, y is greater than 0. So product of two negative integers is positive. So let's look at some more examples. Average of two positive integers is positive. We know अगर हम कोई भी दो positive number लेंगे, उनकी average लेंगे तो it's going to be positive. हम average कैसे लेते हैं? We add two numbers and we divide it by 2. हमारे पास दो numbers हैं, तो we add those two numbers and divide it by 2. So how to express it in mathematical way? So for all AB, if we have two numbers AB, so and they belongs to set of positive numbers, for all AB belongs to positive integers. If we take their average, so A plus B divided by 2, it should also be positive. So this is greater than 0. For all AB belongs to set of positive numbers, A plus B is positive. Average of two positive integers is positive. So next example is the difference of two integers is not necessarily negative. आप दो negative integer लें, उनका difference it could be positive, it could be negative, depending upon के आपका बड़ा integer उनमें से positive है या negative है. आप किस में से किसको minus करें? अगर आप बड़े if you are putting more negative integer, उसको हम smaller integer कहेंगे. For example, -3 and -2. So -3 minus -2. So it become -3 plus 2 is going to be -1. Negative होगा. लेकिन अगर -2 minus -3 करेंगे, difference of -2 and -3. So -2 minus -3. So it's going to be -2 plus 3. So it's going to be +1. So it's not necessarily negative. It could be negative, it could be positive. So difference of two negative integers is not necessarily negative. इसको हम different तरीकों से express कर सकते हैं. It could be like for all negative integers, AB belongs to Z minus. हमारे पास दो negative integers हैं. The difference A minus B, it could be positive or it could be negative. A भी positive भी हो सकता है या negative भी हो सकता है. ये इसको हम किसी और तरीके से भी express कर सकते हैं कि there exists AB for which difference could be positive. I mean, it's not necessarily negative, it could be positive. So there exists AB. हमारे पास ऐसे नेगेटिव इंटीजर्स हो सकते हैं, ए पेयर ऑफ नेगेटिव इंटीजर हो सकते हैं जिसका अगर हम डिफरेंस लें तो वो पॉजिटिव होगा. इट्स नॉट नेसेसरीली नेगेटिव. सो एक ही स्टेटमेंट को आप डिफरेंट तरीके से मैथमेटिकली एक्सप्रेस कर सकते हैं. जो मैसेज है वो एक ही कन्वे होना चाहिए, जो पढ़ने वाला है सुनने वाला है उसको असल मैसेज कन्वे हो जाए कि असल में बात क्या की जा रही है. सो फॉर ऑल पेयर ऑफ नेगेटिव इंटीजर्स their difference could be positive or negative. Yeah, we can also say there exists some pair of negative integers कि उनका difference positive भी हो सकता है. So similarly we can let's do some more example. So absolute value of sum of two integers does not exceed the sum of absolute values of these integers. So this is actually true. It's called triangular identity. So if we have two integers, अब ये integers हैं, it could be positive integers, it could be negative integers. So अगर हम उनको sum करें और उनकी absolute value लें, so sum of two integers and then we take absolute value of sum of two integers does not exceed means it remains below or at most equal to, does not exceed the sum of absolute values of these integers. So integers की absolute value लें और उनको add कर लें. So we can express it mathematically as we have two integers x, y and they belongs to set of z. So it is like integers. So any two integers for all pair of integers. So if we add them up, x plus y, and then we take its absolute value, it's less than absolute value of x plus absolute value of y. Sum of absolute values of x and y. For example, इसको देखें अगर x और y की value 2 और 3 है, so 2 plus 3 is equal to 5, and their absolute value is also 2 and 3, so 5 is equal to 5. So we have equality. लेकिन अगर 2 की वैल्यू माइनस x की वैल्यू -2 है और y की वैल्यू 3 है, so -2 plus 3 is going to be 1 and absolute value of 1 is 1. So on the right hand side we can see x की वैल्यू -2 है, so absolute value of x is going to be +2. absolute value आपकी हमेशा पॉजिटिव होती है. So absolute value of -2 is 2. Absolute value of 3 is 3. So 2 plus 3 is equal to 5. So left side पे हमारे पास 1 था, right side पे 5 है. So 1 is less than 5. So whenever we have a positive number and negative number, so sum of those two numbers and then their absolute value is always going to be less than absolute values sum. अगर दोनों के sign एक से हैं, then it will be equality. So I mean, this is mathematical fact. We have expressed it in mathematical notation. Okay, we are done with this thing. Quantifiers की negation किस तरह करेंगे? So we have actually discussed it before. So इसका formally दोबारा देख लेते हैं. जब हमारे पास universal quantifier है, तो हम कहते हैं कि it is true for each and every value of x. तो ये false कब होगा? If we get an exception जिसके लिए ये true ना हो. If there exists something for which p of x is not true, so हमारी universal quantifier की negation हो गई. So for all x p of x इसकी negation क्या होगी? If there exists some value of x for which p of x is not true, so then it means हमारा जो universal quantifier है वो false हो गया, उसकी negation हो गई. Similarly for existential quantifier, when it is going to be true, when there exists something for which p of x is true, there exists x for which p of x is true. तो इसकी negation कब होगी? If we cannot find at all, we cannot find any value of x for which p of x is true. I mean, for all values p of x is going to fail, then it means we didn't find any value for which p of x is true. So existential quantifier की negation हो गई. So it means for all x, p of x is going to fail. So we couldn't find even a single x for which p of x is true. So it is negation of existential quantifier. So in other words, जब भी हम universal quantifier की negation करते हैं, so universal quantifier is changed into existential quantifier, और जो उसके बाद आपकी स्टेटमेंट p of x है उसकी negation हो जाती है. I mean we have to do both of these things. और जब existential quantifier की negation की बात करते हैं, existential quantifier is changed into universal quantifier, और जो आपका p of x है इसकी negation होगी, negation of p of x. So actually it is nothing but De Morgan's law. Remember, universal quantifier was AND operator, existential quantifier was OR operator. So जब हम AND operation की negation करते हैं, according to De Morgan's law, we get OR operator. OR operator means existential quantifier, और हर एक एलिमेंट की हर एक उसके जो अंदर स्टेटमेंट है उसकी negation हो जाती है. Same thing happens with existential quantifier. इसको हम फॉर्मली देख लेते हैं. So for all x, p of x. So it means this is our conjunction. For all x, p of x means for all, it is true for p of x1, and it is true for p of x2, and it's true for p of x3, and it's true for p of xn. So it's true for all values, and operator है. So when we are going to do negation of it, जब हम इसकी negation कर रहे हैं, so a negation of universal quantifier, it means we are going to do negation of this AND operator, conjunction की negation की. So हमारे पास AND operator है, AND operation हो रहा है और बाहर इसकी negation है, so we can use De Morgan's law. So according to De Morgan's law, AND operator is converted into OR operator, और जो उसके अंदर individual variables हैं उनकी negation हो जाती है. So negation क्या होगी? Negation of p of x1 or negation of p of x2 or negation of p of x3, so on, or negation of p of xn. जितने हमारे पास अंदर वेरिएबल्स हैं सबकी negation हो गई और उसका OR ऑपरेटर हो गया. लेकिन OR ऑपरेटर तो existential quantifier होते हैं. So it means this is existential quantification of negation of p of x, क्योंकि तमाम p of x1, x2, x3 सबकी negation हो रही है. So we can write it down as negation of p of x. It's for there exists x such that negation of p of x. So universal quantifier की जब हमने negation की, it becomes an existential quantifier with negation of p of x. Same thing is true for existential quantifier. We can implement De Morgan's law to prove it. So there exists x for which p of x is true. So it means p of x1 के लिए true है, या p of x2 के लिए true है, या p of x3 के लिए true है, या so on, p of xn के लिए true है, किसी एक के लिए true है. So it's OR operator disjunction. और अगर हम इसका negation लेते हैं, negation of there exists x p of x, so it means we have to take negation of the conjunction, we have to take negation of OR operator, so negation of p of x1 or p of x2 or p of xn. So we can implement De Morgan's law here. So according to De Morgan's law, OR operator is converted into AND operator, और जो आपकी individual statements हैं उन सब की negation होगी. So it become negation of p of x1 and negation of p x2 and negation of p of x3 and negation of p of xn. So this is AND operator. Conjunction is universal quantifier. So this becomes for all x such that negation of p of x. So we have got negation of existential quantifier is universal quantifier with negation of our predicate, negation of our propositional statement. So negation of there exists x p of x is for all x, negation of p of x. So again I repeat, जब हम negation लेते हैं, universal quantifier is converted into existential quantifier, और अगर हमारे पास existential quantifier है, it is changed into universal quantifier. और जो आपकी स्टेटमेंट आपका प्रेडिकेट है p of x, उसकी निगेशन हो जाती है. So this is negation of quantifiers. So quantifier negation, इसकी ट्रूथ वैल्यूज क्या होंगी? इट्स जस्ट अपोजिट टू जो हमने ट्रूथ वैल्यूज ऑफ क्वांटिफायर देखा था. Now its negation, so yeah, obviously it has to be opposite. जहाँ पे quantifier true था उसकी negation वहाँ पे false हो जाएगी, जहाँ पे quantifier false था उसकी negation true हो जाएगी. So there exists p of x, इसकी negation क्या है? Negation of there exists p of x, so it is for all x for which p of x is false. So negation true कब है? For every x p of x is false. और negation false कब होगी? So when quantifier is true. So negation false कब होगी? There is an x for which p of x is true. So for universal quantifier, for all x p of x इसकी negation of for all x p of x. So there exists some x for which p of x is true, for which p of x is false, then this negation is true. So there is an x for which p of x is false. So negation true हो जाएगी. और negation false कब होगी? When it is false for every x. P of x, so when it is true for every x. So negation is going to be false when p of x is true for every x. So as you can see, negation और जो simple statement है वो एक दूसरे के opposite है. Let's do some examples. The first example is there is an honest politician. So इसकी negation क्या होगी? So there is an honest politician means existential quantifier है कि कोई honest politician होगा. I don't think it is true. So there is an honest politician, existential quantifier. So इसकी negation क्या होगी? All politicians are dishonest. So negation is all politicians are dishonest. So we can express this as mathematically as well. So if our universe of discourse is x, so x is set of all politicians and p of x is honest. So it means politician is honest. So there is an honest politician. इसको हम कैसे लिखेंगे? There exists a politician such that he is honest. There exists x for which p of x is true. P of x is honest. X is honest. और इसकी negation क्या होगी? All politicians are dishonest. So अब ये देखिए यहाँ पे universal quantifier आ गया. So its negation is all politicians are dishonest. So for all x, p of x is not honest, means p of x is dishonest. So p of x की negation होगी. For all x, not of p of x. Let's look at another example. So example is all Americans eat cheeseburgers. All Americans eat cheeseburgers. So its negation is going to be all Americans eat cheeseburger. कि जितने भी Americans हैं सब cheeseburger खाते हैं. Negation क्या होगी? अगर हमें कोई एक भी ऐसा American मिल गया जो cheeseburger नहीं खाता, then this statement is not true. So there is an American who does not eat cheeseburger. So we can also express it mathematically. Mathematically कैसे इसको हम express करेंगे? All Americans eat cheeseburgers. So let's start it off. X American, X is American, and let's say eat cheeseburger. So let's call it E of X. So E of X क्या है? X eats cheeseburger. Fine. So E of X eats cheeseburger, or X, we know X is an American. So all Americans eat cheeseburger. So this will become for all X, all Americans, such that E of X, all Americans eat cheeseburger. So this is our statement. So negation क्या होगी? Let's look at negation. So there is some X who is not eating cheeseburger. So there exists some X such that negation of E of X. So there is some American who does not eat cheeseburger. So for all X, E of X, negation is there exists some X for which E of X is not true. Negation of E of X. So let's do another example. What are the negation of these two statements? So for all X, X is some number. For all X, X square is greater than X. So negation क्या होगी? Negation of for all X, X square is greater than X is there exists some X for which X square is less than equal to X. X square is not greater than X. Not greater होगा तो it will become less than equal to. So there exists X, X square is less than equal to X. Please keep in mind जब हम greater की negation करते हैं तो ये less than equal to हो जाते हैं. Never forget equality. अगर यहाँ पे x is greater than equal to x होता है तो फिर यहाँ पे हम सिर्फ less than equal to x लिखते हैं. So यहाँ पे x square is greater than equal to x है. So negation में x square less than equal to x हो जाएगा. Second statement is there exists x, x square is equal to 2. So negation is going to be negation of there exists x square is equal to 2 is for all x, x square is not equal to 2. So x square या तो उससे बड़ा होगा या छोटा होगा. X square is not equal to 2. Next are mixing quantifiers when we have more than one quantifier. So how we use and analyze this, I think we can cover it in next class. Yeah, I think we there are some more examples, so we can do in next class. Maybe we can do this example. So show the yeah, I think we can do it in next class. This is good example. We can do it quickly and then we can finish the class. So we have to show that negation of for all x, p of x implies q of x is going to be there exists x, p of x is and not p of x. So ये implication की negation हमने इसमें use करनी है. So we have statement let's start it off. Negation of for all x, p of x implies q of x. So p of x implies q of x. So we have to implement this negation. So we know this is going to be equal to universal quantifier. So universal quantifier is transformed into existential quantifier, and then we take negation of our implication. P of x implies q of x. So now we have got this implication. इसकी negation हो रही है. Let's highlight it. So we have to do negation of this implication. But we know implication is equivalent equivalent to p of x actually not p of x or p of x. ये हमने last class में किया था. So we can use this fact कि ये जो negation है this is going to be equal to negation of OR operator. So we can simply write it down here. Negation of p of x or q of x. So we can implement De Morgan's law, use De Morgan's law. जिस तरह हमने last class में किया था, implication की negation is going to be p of x and not of q of x. So जहाँ पे हम negation of this thing, इसको हम जब De Morgan's law apply करेंगे, so we will get let's do it. So negation of this thing is going to be negation of negation of p is going to be p of x, and then we are going to have AND operator, and we are going to have negation of q. So this is just like we did in last class. Yeah. So this is same thing that we needed to prove, that negation of for all x p of x implies q of x is same as there exists x p of x and negation of q of x. So we have proven this thing. So next we have to do mixing quantifiers when we have more than two quantifiers. So how we deal with those quantifiers. So we will do it in next class.